So good day, sir. I am Marjorie P. Embellado from 12 Sagacity. In these slides, we are defining the scalar and vector quantity. So, scalar. It is a quantity that has only magnitude, size, or amount, but no direction. For example of scalar, which is mass, temperature, time, energy, speed, and distance. So, quantity is fully described by a single number and unit. It means that standard arithmetic operation can be performed directly on the numerical values of the scalar quantities. Only have magnitude and no directions. So the scalar is only have a magnitude and no directions. So scalars can be added, subtracted, multiplied, or divided like regular numbers. So let's move to the example of the scalars. First is the distance. This refers of the measurement, and it described by its numerical value such as meter and centimeter. For example, the total path length traveled by an object. So the next one is speed. This refers how fast something or the movement. So it described by its numerical value such as meter per seconds. So speed, the rate of motion without considering direction. And temperature. Temperature, it measures how hot and cold it was, and it can be described by Celsius. Temperature, measure of heat energy. The next one is mass. Amount of meter in an object. So this refers to the weight of something and can describe by the numerical value like kilogram, milligrams, and so on. So the next one is, or the last one is energy. Work done or heat. Energy is a ability to change or a movement. It describes by its numerical value such as joules. So let's move to the next, which is the vector quantity. So vector quantity that has both magnitude and directions. So the vector is have a magnitude and directions. So directions. So these are the examples of vector: displacement, velocity, force, acceleration, and momentum. So vector is a quantity that has both magnitude and direction. So a vector quantity is a physical quantity that has both magnitude, size or amount, and directions. Unlike scalar quantities, which are fully described by a single number, vectors require more information to be completely specified. So it refers to the fact that vector arithmetic is different from scalar arithmetic. So because vectors have both magnitude and directions, so you can't simply add, subtract, or multiply them like regular numbers. So that's why vector follow the rules of triangle law, parallelogram law, and multiplication. So let's move to the examples of vector. So here are the examples of vector. There are 5 examples, which is the velocity, force, displacement, acceleration, and momentum. Let's do the first, which is the velocity. So velocity, this refers to a speed and direction. For example is velocity combines speed with a direction like 60 km per hour north. The magnitude here is 60 km per hour and the direction here is the north. So let's move to the force. So force is refers to an pressure or to move an object to directions. The example of this is force of a 10 and upward indicates both strength and the direction in which the force is applied. So the magnitude here is 10 and the direction here is n upward. So the displacement, it has a change of position of an object or something. So example is 50 kilometer east, which is the magnitude is 50 kilometers and the direction is east. So acceleration, this refers to a rate of change of velocity to the directions. So for example 9.8 meters per second square downwards. So the magnitude here is the 9.8 meters and the direction is downwards. And also at the momentum 250 kilogram meters per second southwest and the magnitude is 250 kilogram per second south and the direction is southwest. So don't forget that the magnitude is the 250 kilogram and the direction is southwest. So don't forget that the vector has a both magnitude and directions. So here are the differences between the two. So first is vector. So vector that has both magnitude and direction, while the scalar, a quantity that has only magnitude or no direction. So these are the vector. This has a 5 example and also the scalar. And that's all. Thank you.